Okay, thank you, Gerrit. So, hi everyone. As Gerrit mentioned, my name is Michal Blaho, and I am application engineer for Humusoft. And Humusoft is a distributor, MATLAB distributor in Czech Republic and Slovakia. Today, I will be speaking about modeling decision logic in Stateflow. And I choose Stateflow because I started to use Stateflow probably 17 years ago during my bachelor thesis. And in this presentation, I will show you some projects that in which I used Stateflow. So let's start with some examples of real-world systems. So in these systems, you can find parts which reacts to continuous and discrete changes. And in these discrete changes, or discrete systems can react to some events. So for example, if we look at this rocket launch, the abort system can be triggered by any error in telemetry, for example. So we need to model this kind of systems where something will happen, but we don't know why it or when it will happen. We usually know why it will happen. And we can model these parts in Simulink. So Simulink is good for continuous changes, but we have blocks for discrete changes as well. And in Stateflow, you can model discrete changes and especially these event-driven systems. So what is Stateflow? Stateflow is a graphical environment where you can model a decision logic and event-driven systems. And there are many ways how to model these systems, but Stateflow is using state charts or state transition diagrams, amongst other. But these diagrams are mostly used in Stateflow. So in these state charts, you usually model some modes of your system with these states. And we are transitioning between states with transition based on some events or conditions. So with Stateflow, you can design many types of decision logics like supervisory control, task scheduling, fault management, and many other types. And what's great about Stateflow that is a graphical language. So basically, you are drawing your logic inside the Stateflow editor. And this is more effective than writing thousands of lines of code. So for example, if we look at these examples, you can see that the graphical representation is much more readable and easier to understand than lines of code, which are equivalent to our graphical representation. So I don't want to go too much into the details, but if you want to learn more about state machines, you can watch these tech talks about them. I highly recommend them for you. Okay, and MathWorks has many customers that are using Stateflow in automotive, airdev, machinery, or in project-based learning at university level. So you can read about them in MathWorks user stories. And just to tell you how popular is Stateflow, Stateflow is in top 5 mentioned products in user stories. So behind MATLAB Simulink, obviously, Simulink Coder, and before Embedded Coder. So Stateflow is very popular among like customers, MathWorks customers. So I will start with the first project, which is the traffic light. The goal is to model this sequence of LEDs that we all know probably, and we will have 2 states, standby and operational. In standby, and this can be used, for example, for maintenance, so yellow light will be blinking, and in operational mode, the light will be showing, as we all know. So let's jump into the Simulink, and I will show you how to model this in Stateflow. Okay, so this is our Simulink model, and to model something inside the Stateflow, we first need to insert Stateflow block. So we can go to Stateflow library, and we will use this chart block. Okay, now if we double click on the chart, the Stateflow editor will open, and here we can build our logic. So I will start with state. We can call this state standby. And at any point during your editing, you can use these objects that you can insert into the Stateflow editor. So now we can make this state a little bit bigger, and we can insert another state inside this standby. Because Stateflow supports hierarchies, we can call these states off. And nice thing about Stateflow is that when you're editing your charts, Stateflow will try to help you find some errors or warnings during your editing. So if I put unnamed state inside our chart, Stateflow will give me some warnings, some errors. So this time, Stateflow detected that we cannot reach this state. I will call this state on. And it's because there is no transition between this off and on state. So I can make this transition. And now Stateflow will say that everything looks good. Another thing that I like about Stateflow is speed of editing. So if we drag transition from our state, Stateflow will recommend us the next object that we can use. For example, this on state. And we can also use right click on the state and copy this state as well. And the next thing that Stateflow is good at, it's guessing names. It only works for on and off, high and low. But if I copy this off state, Stateflow will recommend the next state as on. Stateflow will also recommend you transition, all possible transition types. So I can choose this type of transition. So now we have states, now we have transitions. In fact, we had transition already in our chart. So these arrows with circles, they are representing default transition. So for Stateflow to be deterministic, this transition is telling Stateflow where we want to start. So we want to start in standby and in off state. So now when we transition from off to on and from on to off, so we must double click on the transition. And again, MATLAB or Stateflow editor will help us. So it will recommend us syntax for transitions. So we should probably write some events, conditions, and actions. But in this example, we will react to time. So I can write after, which means that we will transition from this state to this state after 1 second. We will do the same for this transition. And now we are able to switch between two states after some time. You don't need to worry about timing. Stateflow will take care of everything for you. Okay, so next what we need to do is set some data. So data are set basically in states or in transition. We will use states. And in states, we can react to 3 events on entry, which means when we enter these off states, we will set, for example, yellow light to 0. And in on state, we will on entry set yellow to 1. Okay. And we have also red and green light, so we can set the variables in default transition. So red will be 0, green will be 0. Now, if we return to Simulink, you can see that our chart has some variables, but we don't have any ports. And it is because we need to define scope of these variables. So we can go to this symbol pane, which is a really nice, cool feature in Stateflow editor, where you can set all your variables, inputs, outputs. So you can resolve these symbols, or we can define them manually. So we can set them as output data for all the colors, And now we should have ports for our signals. So now I must set up these lamps to proper signals. So red, this should be yellow. And this should be green. And now we can run our simulation. I will set up some pacing to make it a little bit faster. And now, based on our logic, we should see this yellow light blinking. So this is some basics how you can develop your basic logic in Stateflow. And to save us some time, I can open the finished model. So the complete model should look like this. And what's nice about Stateflow, it's the readability. So if you would probably show this state to someone, I think they will be able to guess what this chart is doing. So we are starting in prepare to stop, then we are moving to stop, prepare to go, and back to prepare to stop. To transition from operational to standby, we are using these two transition with variable run, which is signal in Simulink. So once again, I will set up slightly better speed. And now Stateflow will run in standby, and then we will switch to operational and back to standby. Okay, so that was our first project, the traffic light. And the next thing that we may want to do is to analyze our chart. So there are many possibilities how to do that. So we can do it visually by breakpoints in sequence viewer. And new addition is this activity profiler that I really like it. I think it's a great tool. So let's go back to Stateflow. I will turn off pacing, I think, and make it medium. Okay, so the first type of analyze, we can do it with this just visual analysis. So we just run our model, and here you can see how the states are switching. The blue color show or symbolize the active state or transition. If you want to debug this chart, we can click on any state and add breakpoint to it. And if we run the simulation, Stateflow will stop at your selected breakpoint. And now you can step through the simulation. And this is a nice way to learn how Simulink is or Stateflow is working. So how Stateflow change the states, what he is doing in states, and so on. Okay, so I will speed up a little bit the simulation. And now we can look at this sequence viewer. So before we can look at sequences, we must log states and events. And now if we run our simulation, I forgot to turn off this breakpoint. Continue. Then in this sequence viewer, we can see how states and transition were switched in this like timeline manner. So you can check how your states were switched. And the last feature that I mentioned is this activity profiler. So you can turn on this activity profiler. I will place it here. And after you run your simulation, you can see which state and transition were used most. So I will change the color scheme for you to see it better. And now you can see that these two transitions were used the most, and the stop state operational and standby states were used most. So this is really nice, cool feature of 2020B release. Okay. So now we can step it up a little more because you can model complicated things in Stateflow. So at our faculty, we had this.
Sorry, sorry to interrupt you. So this was a great little demo. There was quite a few interactions in the chat you don't know. Maybe just a quick question from me. So this activity, Stateflow activity chart that you were showing, can you just share a few words of, is that the same thing as a Simulink profiler, or is this just kind of counting the number of times each state/transition is achieved, and I saw those different colors. What was that? Is that like percentage, like the top 20%? Is that to identify bottlenecks?
Yes.
You did that very quickly. Sorry. Yeah, I'm interested.
I can run it again. But without pacing, I think. Okay, so Stateflow is counting like the usage of states and transitions. So here we have some like areas. What color represents how often you are in these states or in transitions. So the count is here in this table, and color represent like this.
The percentage
of use, yes.
It's normalized, is it? It's normalized. Okay.
Yes, I think so.
Okay. Very cool. Very interesting.
And it's more like, I think, Simulink coverage. But in coverage, I think you can do much more. This is like just overview of states and transition that I used most, I think. So basically, if you hang in one state, it will probably turn red.
Yeah. Thank you. Yeah, it's clear. Thank you for that.
Okay. So are there any other questions, or should I continue?
No, in general, people are liking it. They like what they saw, and there's a few little tips that you did that triggered a bit of attention, like the red button. You changed the speed of your execution speed. You did this as if you made it sound like everybody in the planet knows that. So not everyone does.
So I want to show a lot of things, so therefore I am running at a fast pace.
It's good. Keep going.
So these training models, basically at our university, we have these training models, and these training models are used for teaching students to program PLCs. But of course, I saw this as opportunity to program them in Stateflow. So I borrowed one model, and basically I developed control logic to perform sequence of operations. So this model has 4 inputs and 4 outputs. So 4 sensors and 2 motors with 2 directions. And to not work with a real model, I built some virtual model in Simulink as well. So we can jump into the Simulink, and I will show you the final Simulink model. So here we have my control logic. Here is 3D visualization, so I can run it probably on the background. And this chart is a little more complicated. We have safe mode, which is used for normal operation. Fail mode, when something goes wrong, we will shut down motors. And in safe mode, we have 3 parallel states. So parallel states are with these dashed borders. So what I'm doing here is initializing with this homing state. Then here is this control cycle, which is used for the whole control process or operation of this machine, and fault detection, which is for detecting if motor is turning some long time, and that means usually that brick is stuck somewhere on the machine, or the sensor is not working properly. So this is like the more advanced model in Stateflow. And we tested this on the real device. So we turn my computer into a real-time machine with use of Simulink Desktop Real-Time, which is a tool that is developed in Prague. And with some data acquisition board and some electronics, we were able to hook up to this device and control it from my computer. And here in the background, you can see I'm using the same control logic to control this machine in real time. So all works really well. Now, the customers are building even more complicated systems. So just to show you, I will open this Airbus user stories, and here you can see that they developed fuel management systems. They got 21 pumps with 43 valves. They had over 1,000 requirements, and written or write code for such complex system when requirements may change is quite achievement. And of course, they used Simulink and Stateflow, so they built 45 charts, 6,000 states, and 8,000, nearly 9,000 transitions. So this is like a nice user story how Stateflow can be used for really complicated stuff.
So Michael, maybe just a quick question that came in from Adam is like, did you anytime put any effort in some performance optimization of complex Stateflow charts, or is it rather does not make sense due to the simple operations that are usually used within the charts? So I guess the question is a bit of scalability and if there are tips and tricks to improve performance of large complex state charts.
So with large charts, you can use I don't know what to call them, but you can like encapsulate these states. So you can make like subcharts, and you can design your parts like separately. So this makes it more readable. But I did not use any kind of optimization technique. It's just writing your model and test it in operation or in simulation.
Thank you. Maybe another question that came through while you're at it is someone called out, Yoda called out that you can actually use Stateflow from MATLAB without necessarily using Simulink. Have you seen some nice applications for that?
Yes, so I typically work with hardware, so that's why it's for me better to use it in Simulink. But certainly you can use the Stateflow from MATLAB. And I saw one application for data acquisition, one application for fitness. So if you look at Stateflow demos, there are some quite examples how you can use Stateflow in MATLAB as well. And you can control app designer applications with Stateflow as well. I think that is like typical demo for MATLAB usage.
Yeah, thank you. And maybe just one last question. This comes from Yoris. He was kind of interested in that DAC that you had in the video. Can you maybe speak a little bit about that and how you made Simulink driving hardware? You mentioned that very quickly. Can you spend a few more words and explain that a little bit better?
Okay, so to connect to your hardware from your desktop computer, you can use a tool called Simulink Desktop Real-Time. So basically, instead of input and output blocks, so like constant and scopes, you can use specialized block that can communicate with data acquisition boards in real time. So with this setup, you can use like any machine that can connect to this acquisition board. And this device, which converts standard TTL 3 volts logic to 24 logics, because PLCs are using 24 volts. So this is just device to convert to that range of signals.
And just as a sanity check, is that a Mac in the screen, or
yes,
my eyes perceiving me incorrectly? That's connected to a Mac?
Yes, so it works with Mac because we designed this data acquisition device which works on Mac as well. So I think it's the only measurement card that you can hook up to your Mac and measure some signals with it. So you can check out our web page for that, I think, Humusoft.
Thanks. Please continue. Very cool.
Okay, thank you. Okay. So how do we transition from Stateflow to something real, some real production? So in industrial automation and machinery, you can typically use, or typical device to use is these PLCs, programmable logic controllers. And they have quite nice benefits like modularity, resistance to environment. So because our model were designed for PLCs, I try to convert my model for the PLCs. We can do it for PLCs, but it works with other devices as well. And for that, we can use these nice tools from MathWorks that are for code generation. So basically, from Stateflow, you can develop your algorithms or convert Stateflow chart to C++ code, HDL code, or to PLC code, so structured text. So I did that. So I convert my chart with help from a PLC coder to structured text, and with help from my former colleagues, we were able to implement this code into the Bradley PLC and Siemens PLCs. So if we have time, Garrett, I can show this demo as well. It shouldn't take long.
No, take your time. It's interesting.
It's your call.
Yeah. No, take your time. So I think it's useful because there's about, I think there's about 25 people on the line, and I think 8 of them use Stateflow. So and the ones that don't use it or haven't used it, this is interesting to show it. So please go ahead and use it. Okay, so maybe a little bit of how the code is generated from Simulink to PLCs. So in this model, I have just this control logic. And logic is encapsulated in a subsystem block. So to convert this subsystem into code, we can go to apps, PLC coder. We will select that we want to deploy or build code for this block. In settings, we can set up your vendor IDE. So if you are working with some specific PLC, you can select your provider. I will generate generic code. And now we just hit generate code, and PLC coder will do all the hard coding for us. So after a while, we should see that code generation is successful, and your code should be in this PLC SRC directory. Nice thing about code generation is traceability. So we can open a report. Then you can inspect your code. And from code, you can navigate to state or transition that is responsible for your part in your code. So if you click on this link, Stateflow will jump and highlight the state that is responsible for that part in your generated code, and it works both ways. So if I click on the another state and click here navigate to code, this will
bring me into the section in code. So this section is responsible for that state. So this is nice way as well to learn about your generated code. And most of the people that are using Simulink or Stateflow doesn't have probably access to PLCs, so you can use low-cost hardware like Arduino's Raspberry Pi or LEGO Mindstorms. Stateflow works with all of them, so we did that, and we built this LEGO Mindstorms color sorter when we just detect this green brick and move this color sorter based on encoder values. So this is simple logic to control that device, and you can look at it at this file exchange entry. Okay, so how you can learn about Stateflow, but many other things. In MATLAB, you can visit this link or Google MATLAB Academy. And this is great site for learning something. These on-RAM courses are for free, and you can learn like nice things about all the products or many products that are popular. So, for example, deep learning, machine learning, controls, and so on. So MATLAB Academy as well. So thank you. That's all from me.
Thank you very much, Michael. That's very cool. That's really, really interesting. Just maybe one question before we change presenters. Yodis is actually asking, is it possible to, went from structured text to the state machines. The question is, in the code generation to C or C++, is it possible to have that traceability the same way you did it for the structured text?
Yes, you can trace basically with every code generation inside MATLAB and Simulink, I think.
Very cool, very cool. So you're getting lots of congratulations, virtual high fives and clapping. So thank you very much for your presentation, Michael. So thank you.